Hello, welcome to the first day of our new chapter. Today we're going to learn about is inverse trig functions. Well, first let's look at y equals sine of theta. Y equals sine of theta. Um, First, let's think about the domain of the angles. What angles can I fit in here? Well, I can fit in any angle from negative infinity to infinity. What's the range of the ratios? So for the y, the 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 highest y I can get is 1, and the lowest I can get is negative 1. So that's going to include both negative 1 and 1. So the range of the ratios are between negative 1 and 1. Now if we look at the inverse sine of y equals theta, the domain is the ratios, and the range is the angles. So we could do some of these on our calculator. Inverse sine of 0.1 and the inverse sine of point. First, make sure your calculator is in degree mode. And inverse sine of 0.1 is 5.739, so that's in degrees. And then if I did that of negative 1, it would be negative 5.3. Oh, sorry, I can't talk quite yet this morning. Negative 5.3739. Jeez. Hopefully I get better on this talking thing through this video. The inverse sine of 0.3 is 17.457. And if I do the inverse sine of negative 0.3 in my calculator, I have 17.457. Inverse sine of 0.5, that'll give us 30. And inverse sine of negative 0.5, that will give us negative 30. Finally, our last one, we'll do 0.8, which is 53.1, and this one will be negative 53.1. Now, as this gets closer and closer to 1, this number will get closer and closer to 90. As this gets closer and closer to negative 1, this number will get closer and closer to negative 90. So we know the sine function looks like this, but the principal branch, the one that we'll use for the inverse sine, only goes from negative 90 to 90. So the principal branch of sine looks like this, from negative 90 to 90. Because when we're doing the inverse, that inverse has to be a function. And if we continue this, it will no longer be an invertible function. So the domain of the angles are from 90 degrees to negative 90 to 90. The range of the ratios of sine are between negative 1 and 1. But in the inverse sine, the domain and the range are flipped around. Now on the unit circle, negative 90 is down here and 90 is up here. So inverse sine will only be using these two quadrants, 1 and 4. Now we can do the same thing with inverse cosine. The domain of the ratios will still go from negative 1 to 1. The range of the angles we can figure out by plugging these numbers into our calculator. If I do the same thing with cosine, inverse cosine of 0.1, I get 84.26. Now if I do inverse cosine of negative 0.1, I get 95.73. Actually 74 if I round it. Now, what do you notice about those two numbers? We'll keep that in mind as we do this next one. If I have 72.5 and 107.5, both of these numbers are supplementary. Both the positive 0.3 and the negative 0.3 will give you supplementary angles. If we keep going, this will be 60 and 120, and then this will be 36.9 and 143.1. Now, notice how none of the angles are negative here. So the range of the angles here gets closer and closer to 0 as it gets close to 1, and closer to 180 as inverse cosine gets to -1. So the range of angles, well, I should say the range of angles, yeah, this one is from 0 to 180, and 0 and 180 are included. All right, so cosine's principal branch goes from here to here. So if I draw it out, it goes from 0 to 180. That means in the unit circle, it's quadrants 1 and quadrants 2. And this stuff we've already went through. All right, let's look at inverse tangent of y, the domain of the ratios. Now, the ratios for tangent can go from -infinity to infinity. And the range of the angles just goes from -90 to 90, just like, actually, just like sine. However, the one difference is this is undefined at -90 and 90. Remember, there's the asymptotes here and here. So this in between here is our principal branch. And our asymptotes are on each side at -90 and 90. So that means on the unit circle, we're just dealing with quadrants 1 and 4 again. All right. So if I asked you what interval is the inverse cosine of -1/2 in? Inverse cosine is going to be in one of these two quadrants. So we can draw our two reference triangles. And it's 1 over 2, 1 over 2. In quadrant 2, it makes a -1/2, where in quadrant 1, it just makes a +1/2. So it has to be between 90 and 180 where this answer lies. Inverse tangent of -1. Inverse tangent we decided was in quadrants 1 and 2. So if I draw my two reference triangles, opposite over adjacent has to be -1 over 1. In quadrant 1, it will just be positive. So this is between -90 and 0. Now, some people will look at answer E and think that it's between 270 and 360. And that angle would be coterminal with this. But remember, the inverse tangent has to be between -90 and 90. So there's no way it could be, we couldn't get a value in between 270 and 360 from that. Inverse sine of 3/4. So if I do these, the opposite over the hypotenuse has to be 3/4. And it's going to be -3/4 in quadrant 4. So it has to be in quadrant 1. So that's 0 to 90. Now if we have x, that means we're dealing in radians. So inverse cosine of 1/9. Cosine is in quadrant 1 and 2. So 1 over 8, 1 over 8. Over here it's going to be negative. So between 0 and pi over 2 is where our answer will lie. Tangent of 3 over 2. Tangent is in 1 and 4. So 3 over 2. This would be -3 over 2, so that won't work. So it would also be between 0 and pi over 2. Inverse sine of -1/2. That's in quadrants 1 and 4. 1, 2, -1, 2. The top would give you a positive answer, so that won't work. So that's between -pi over 2 and 0. All right, now we're going to start looking for more specific answers. The inverse cosine of -√2 over 2. So we can do this without a calculator because inverse cosine is in these two quadrants. Now, when we do this, we better have good knowledge of our 30, 60, 90, and 45, 45, 90 before we start this. We know that our 45, 45, 90 is the one that gives us answers that look like this. we can draw a triangle where it's negative root 2 over 2 and 1, and root 2 over 2 and 1 for a 45, 45, 90 triangle. So it will only be negative on this side, and if that's a 45-degree angle there, my theta goes from 0, passes 90, and stops short of 180 by 45 degrees. So 135 degrees is the answer. Inverse sine of 1/2. Sine is in quadrants 1 and 4. We have 1, 2. It can't be down there because that would be negative. This is going to be a 30, 60, 90 triangle, and this will be opposite of the 30-degree angle. So 30 degrees is our angle. Inverse tangent of negative root 3. Inverse tangent is in these two quadrants. We have root 3 over 1, negative root 3 over 1. It has to be here because that's where it's negative. And across from the root 3 is a 60-degree angle, and it's going to be going down 60 degrees. So negative 60 is our answer. Inverse sine of root 2 over 2. We know automatically that's a 45, 45, 90 triangle. And it's positive, so it's going to be up in quadrant 1. So root 2 over 2, 1. This is 45 degrees. So in radians, that's pi over 4. Inverse cosine negative root 3 over 2. Cosine is in quadrants 1 and 2. It's going to be negative up here, negative root 3 over 2 over 1. That means this side would be 1/2, and this angle would be 30. So that angle there in radians is going to be 5 pi over 6. Inverse tangent of negative 1. So if I look at tangent in quadrant 1 and 4, we'll have negative 1 over 1. And so this 1 and 1 will help us know that it's a 45, 45, 90 triangle. So since that's 45 degrees, I'm going to, in the opposite direction, pi over 4. So hopefully I have some answer down here. Great, negative pi over 4. Inverse sine of negative 1/2. So inverse sine is in these two quadrants. Negative 1 over 2 would look like this. That would be a 30-degree angle. So that's 30 degrees down. So that's going to be negative pi over 6. All right. Now if I want to take the inverse cosine of the sine of 120 degrees. First we need to do the what's inside the parentheses. 120 degrees is going to be out here, leaving a 60-degree angle, 30. So the sine of that is going to be root 3 over 2. So now I want to take the inverse cosine of root 3 over 2. So the inverse cosine is going to be right here, root 3 over 2. And the angle that will be represented here, if we finish the triangle, will be 30 degrees. Tangent of 135. 135 is off in this direction. Tangent at 135 is going to be 1 over negative 1, so that's negative 1. So I have the inverse sine of negative 1. Now the inverse sine of negative 1 means my opposite over my hypotenuse is going to be negative 1. So for my opposite side to be negative 1, and my hypotenuse to be 1, that means this angle would be right on this axis. So that would be negative 90 degrees. All right, so without your calculator, find the tangent of the inverse cosine of 3/5. So the first thing we need to do is sketch where the inverse cosine of 3/5 would be. So that would be 3 over 5. Now the tangent is opposite, which would be 4 over 3, which is the adjacent. Sine of the inverse cosine of 3/5. So cosine being 3/5, the sine will be opposite, which is 4, over the hypotenuse, which is 5. Sine of the inverse tangent of negative 12 over 5. So tangent is negative 12 over 5 over here, negative 12 over 5. And now the sine is going to be the opposite, negative 12 over the hypotenuse. This is a 5, 12, 13 triangle. So negative 12 over 13. Cosine of inverse sine of x. So we're generalizing it. This is going to get a little trickier, but if we have x, that means sine is x over 1. So if I want to find the adjacent side, I know b squared plus x squared is equal to 1. So if I subtract x squared on both sides, and then I square root it, so the cosine of that will be plus or minus square root of 1 minus x squared. Now it depends if x is positive or negative. If x is positive, then this will be positive. If x is a negative number, then it will be a negative number over here. So the cosine of this will be this adjacent side over the hypotenuse, which would just give us a plus or minus 1 minus x squared. All right, let's try it again for sine of inverse tangent of x. So tangent is opposite over adjacent. So x, because x is like x over 1. And now to find the hypotenuse, I do 1 squared plus x squared equals c squared. Square root both sides. So I have plus or minus 1 squared plus x squared equals c, which is just the square root of 1 plus x squared. Now it would be positive if it's, actually this would be positive everywhere because the hypotenuse is always positive. So we don't even, a negative doesn't even make sense in this situation. So the sine is going to be opposite, which is x, over my hypotenuse, which is 1 plus x squared. And if I rationalize this, it would be x times 1 plus x squared all over 1 plus x squared. All right, now you have a worksheet. Good luck.